All right, so we're going to start our unit review for the final exam. And there's a whole bunch of problems here, so we'll break this up into several smaller videos and kind of go through them chronologically. So Unit 1 and Unit 2 to start, a lot of stuff with functions here. So we'll just jump in and start working through these. So problem number one asks me, state if the graph is a function or not. If not, why not? So we're going to just go ahead and think back to what we did in Unit 1. Something is a function if every input has exactly one output. And what that looks like on a graph, like we see here in A, B, C, and D, is if every input, every x, has only one y. So if we have 2 points on top of each other, like here and here, right, that's bad. Or here, or here, or here, right? And we talked about the vertical line test. If I have a graph and I can draw a vertical line through the graph at any point and it touches more than one point on the the actual graph, then that's a bad function, not a function. So if I look here, number one, A is a function. It's a linear function, right? There's nowhere I can draw a line through here that it's going to touch more than one time. Same with C. There's nowhere I can draw lines through C, right? That's also a function. Whoops, sorry. In the wrong box, right? C was a function. B was actually this one right here. We already saw this is not a function because there's places on the graph where 2 points are directly on top of each other. So B is not a function, right? And it says if not, why not? So we could say it failed the vertical line test, or we could say there are places on there where the inputs, right, the x, have 2 outputs. Right? So there are places on here where the x, like for example, when x is 5, there's 2 different y's that go with 5, so that's not a function. And D, if I draw the lines, there's no place that it hits twice, so that's a function. So the only one that was not a function is B. All right, so continuing on, number 2. The bird flies out of its nest. This graph represents the distance it flies from the nest as a function of time. State if these statements are true or false. So one important thing to remember here or to recognize is that this graph represents the distance it flies away from the nest. So it's not the total distance flown, but how far it is away from the nest. So if I look here, it's starting at the nest, it's flying away from the nest, and then back towards the nest, then away again, and then back towards it, and then he arrives back at the nest here at the end. So let's use that to answer these questions. The bird's greatest distance from the nest happens at about 7 seconds. So I go over to 7 and up, and I see that is the highest point, right, the biggest Y, so that would be true. Part B, the bird returns to the nest at about 8 seconds. So it went away, towards, away, and all the way back home, and he got back home here. That looks to be somewhere right around 8.8 seconds, so that is also true. And remember, as I'm doing these, right, if you just copy down the true or false or the letters or whatever, I mean, you're really not getting out of this what I'm hoping you will, right? The value is in understanding what problems are going to be coming at you on the final exam. Okay, C, the bird's greatest distance from the nest happens at about 2 seconds. So if I look here and go up, right, that's not the greatest distance. We already said the greatest distance was up here at 7, so that would be false. D, the bird was closer to the nest between 2.5 or 3 seconds than it was at 2 seconds. So let's see, at 2.5 to 3, so this area right here, is he closer than at 2? And that's true, right, because he was coming back during that time, so that's true. Right? The Y is lower there. E, between 4 to 6 seconds, so between here and here, the bird was getting closer to the nest. That's not true, right? It's going further away from the nest. The distance was increasing, so that would be false. All right, number 3, determine the outputs for the following functions. So these were those function machines, and remember, we drop in a 3, that means I always, when I'm evaluating, I want to put parentheses around just the letter. Doesn't matter, like here on part B, if it's inside other parentheses, right, we want to put the parentheses around just the letter every single time, and that's going to help us keep our signs straight when we evaluate. Okay, so we go ahead here and we're going to drop a 3 in right there. They didn't leave us a lot of room to work on these, so I guess we'll just do it. I'll actually do them, just do them here on the side. Okay, so we have x squared, so my x is 3, 3 squared minus 1. All right, so 3 squared is 9, minus 1 equals 8. Right? So f of x would be 8. And the way I would, my notation, right, this really should say f of 3, because the x was 3, equals 8. This would be like the best answer, a representation of my answer. Okay, let's pick a different color for this one. So we have a 6, and we're going to drop it right in there. So we're going to go ahead and we have 6 minus 4 squared. All right. I don't really need the parentheses there this time, but it helps, like you'll see on this other one, the third one we do, it's going to help if I use the parentheses to keep my sign straight. So in here, inside the parentheses, 6 minus 4 is 2, still squared, and 2 squared is 4. So if I put in a 6, I got out a 4. All right, and I should really say f of 6 equals 4. And then the third one over here, right, you can see why maybe on this one I'm using parentheses. So I have my parentheses here, and I'm going to drop my negative 2 in where I see the x there and there. So x was negative 2. See, by using the parentheses, I'm going to keep the sign straight. Not so much for that one, but for this one on the bottom, it's definitely going to help. So 7 minus, and I put my parentheses where the x goes, and the x is negative 2. Right? So what I saw from a lot of students earlier this year when we did these was if it was 7 minus x and they were substituting in a negative x, they just would write 7 minus 2, right? But I have to recognize that it's 7 minus negative 2. All right, so negative 2 plus 3 is 1. And on the bottom, 7 minus negative 2 becomes 7 plus 2 is 9. So if I plug in a negative 2, I get out 1 over 9. This would be like my final answer. All right, so we're going to go on to the next page. Probably try and do 2 pages here per video. Billy buys light bulbs in packs for $20. The shipping cost is $10 regardless of the number of packs bought. Billy only has $120 to spend. The cost of the light bulb with respect to the number of packs can be modeled by a function. Select the statement that correctly describes the domain. So this is probably a little bit different than most of the problems that we've seen. We didn't really do domain so much with word problems. So let's kind of take a second here and see if it doesn't really ask me to write the function, but I kind of have to figure out the answer. So let's just write the function. So I know the function, right, how much it cost, the output, right, the input, the x is going to be the number of light bulbs, right, the output is going to be the cost. There's a $10 shipping fee, so that's like the starting value or the y-intercept, and they cost $20 each, so that's like the rate of change. That's how much we multiply by each pack. So I can write an equation with this information right here. So the amount that I'm going to spend on light bulbs is I'm going to spend $20 multiplied by how many I buy, and I have to add on $10 for shipping. So this is my my equation, and what it's telling me down here really is that the y is $120. That's my maximum I have to spend. So what this is really asking me for is what values of x could I plug in here that will make this true, or will allow this to be true, right? So let's take a look at our options. So here's my equation I'm going to think about right here, right? I know how much I have to spend, 120. I know how much they cost. I know what the shipping is. What I want to know is how many can I get? That's what it's really asking me. If I have 120 bucks, how much can I get? So the domain, the possible x's, are all integers greater than or equal to 10 and less than 110. So that's not true, right? If I plug a 10 in for the x, that would be 200 plus 10 would be 210. That'd be too much. I can't buy 10 or 110 boxes. It's too expensive. So the domain is all integers greater than 0 or equal to 120. Right? Well, I could buy 0. I can always buy 0, but I can't buy 120 packs for $20 each. That'd be $240 plus the shipping. That's going to be too much, so it's not that one. The domain is the set of all integers, so just whole numbers. I have to buy a whole number pack. I can't buy half a pack. Greater than or equal to 1 and less than or equal to 6. Well, let's see. If I think about this part right here, the 6, can I buy 6 packs? 20 times 6 would be $120 plus the 10 for shipping would be $130. That's too much. So I can't use that one. That really only leaves one, but let's make sure. The domain is the set of all integers greater than or equal to 0. So can I buy 0 packs? I can always buy 0 packs, right? If I buy 0 packs, well, this would tell me I have to spend $10, but that's okay. And then over here, 5, right? If I buy 5, I put a 5 in here. 20 times 5 is 100, plus 10 is 110. So that's allowed because that's within my budget. So the correct answer here would be D. All right, number 5, simplify the following expressions. So this is really just combining like terms. All right, let's use a different color. So we're going to try and see where I can combine. So I know I can combine these guys because they have y's, and I can combine these ones because they're constants. So I can 4y minus 2y would give me positive 2y, and negative 8 minus 4 would be negative 12. So 2y minus 12 would be how I would simplify that one right there. This one down here, let's see. This first term, 28, has an x. Next one has a y, then an x squared, then a y, then an x. So I see there's an x here and an x here. And there's a y here and a y here. Right, that x squared in the middle, there's no other terms that have an x squared, right? I can't combine x's and x squared, so I'm going to end up with, let's just write it, 4x squared. That part's going to stay the same. Then my x's, I have positive 28 over here and negative 3 over here, so I end up with a total of 25 x's. And I have negative 6 y's and positive 30. So 30 minus 6 is a positive 24 y. All right. And C, if I look here, I have 5y squared z. This is a y squared z. So the exact same combinations of variables. If they're exactly the same, right? This has x's and y's, and there's a y squared, but they're multiplied together. The only ones I can combine are the two that I've highlighted there. So I'm going to end up with 5 minus 2 for 3 y squared z. And then I didn't do anything with the other one, so I just bring it along. X, y squared. So combining like terms has to be the exact same variables. All right, number 6, given the formula K equals 1/2 mv squared. So this is a formula you'll encounter in physics for kinetic energy. K is the kinetic energy, m is the mass in kilograms, and v is the velocity in meters per second. So it's asking me here, here's the question, write the appropriate measurement for the unit of kinetic energy. So what are the units, right? What are the units? This is something that's really helpful if you understand this when you go into physics and chemistry and some math classes. If I understand like what the units are, I can actually figure out what the equation is and vice versa. So K equals 1/2 mv squared. if I just plug in the units, right? 1/2 doesn't have any units, that's just a number. M is the mass, that's kilograms. And velocity is meters per second, and it's squared. So if I'm thinking about just the units, I can kind of forget about this part here for a second, and I'm going to end up with kilograms and meters over seconds squared. Remember our exponent rules, right? If I have something inside raised to a power, it's going to go with both. So I'm going to end up with meters squared, seconds squared. So my units for kinetic energy are kilogram meters squared per second squared. And you'll realize or learn later on that there's actually another unit that makes this simpler. We can call that something else. But right now we'll just call it kilogram meters squared per second squared. All right, 7. Given the formula D equals mv, where D is density, m is mass in kilograms or pounds, and v is the volume, right? So density is how like heavy something is really, right? Like per how heavy it is per size, per volume. So D equals mv. M over v, sorry. And again, it's asking me to write the units. Well, M, the mass, is kilograms. We could pick pounds, but let's pick kilograms. And V is as cubic feet. Well, all right, well, I guess we'll go cubic feet. So feet cubed. Normally, we don't mix like the English units like feet and kilograms, but that's okay. They did it here. Okay, so kilograms per foot cubed. That's it. That's my units right there. Just substitute them in like you would anything else. All right, last one in this video. Number 8, for the equation below, state if it was solved correctly or at what step the error was made. If the error was made, then solve it and correct it. So choose letter A, B, C, D, or E. If the error was made, solve correctly. Those are kind of redundant, but basically it's asking me to solve this equation and see if they did it right. If they did not do it right, where did they go wrong? So we're going to start here. And I think a good first step would be to distribute. So I need to distribute this and distribute this and lay everything out. So 5x, actually, you know what I'm going to do is I'm going to write it out and then compare to what they have. So if I distribute that, I'd have 5x minus 10. And I still have minus 4, and then I have 2 times x is 2x plus 2 times 3 is 6 minus 11. That looks exactly like what they have here, so that means this step is correct. All right, now I'm going to go ahead and combine like terms. So if I look here, I see I have constants there and there on the same side. So I'm going to go ahead and combine them. So I should end up with 5x minus 10 and minus 4 would be minus 14, plus 6 and minus 11 would be, 6 minus 11 would be negative 5. So if I compare to what they have in step 2, right here and right here, they have different things, right? Because they did not keep the signs straight. So this is not correct. So this is where they made their mistake. So I would answer the question, where is the error? The error is in step 2. And then it asked me to correct it. So I know that I feel pretty good about what I did up to that point. So I'm going to write that over there, and then I'm just going to solve it. So let's do it this way. Might be too far down there. So let's add, actually let's subtract 2x from that side to get rid of it, and the same over here. And then let's add 14 to get rid of this, and the same over here. negative 5 plus 14. That really is the same thing as 14 minus 5, which would give me 9. And then if I divide both sides by 3, x equals 3. Right, so you can see what they came up with here was not correct because these two things here gave them something different right there. All right, so chugging along here. We're 8 problems through. We got a whole bunch more to go, so check the other videos for the other problems.